Go ahead.
Well, thank you, everybody. It's an honor to be with all of you this morning, well, or afternoon as it's on the East Coast. I'm Bill Pekny. I spent 27 years with the U.S. Army, 23 of it on active duty as a soldier scientist, and another 20 years in the aerospace industry. I grew up in Chicago, and then on my first assignment in active duty in Utah, met a young lady from Utah, and we married in 71. And next week will be our 54th year together. And so today, Elizabeth, I'm going to share my slides now with you, and we'll get started and talk about uh, Earth stuff. Okay, you should be able to see my slides now. Can you see that?
Yeah.
Okay, so that's my book. And I wrote it in retirement after my 47-year career in the workforce, and it's about this controversial topic of climate change that's uh, been with us for several years now, and so what it's about is the physical evidence of a supposed climate doomsday, and what I think about it, and in terms of physical evidence, and then I'm presenting this today to you so you can decide for yourselves. Not You don't have to believe what I say. There's a lot of references, so you can see both sides of the story, and that's what this book is about: is uh, showing the two sides and what's going on today. So yesterday I spoke also, so I'm just going to give you a quick set of highlights from what I talked about yesterday, which continues on today in a little different vein. But the first one of the highlights from yesterday is this disclaimer that I start with all the time. As I said, I'm a retired soldier scientist, and I'm not beholden to anybody. My income comes from these sources, and I'm not paid by anybody else to present a specific position, not the government, not the fossil fuel industry, or anybody else. And so this is my disclaimer that what I do is because I love to do it, and not because anybody's paying me to do it, other than the retirement income that I've got and the book sales that I have. And so that's it. No, there's no grants, gifts, subsidies, whatever. From the fossil fuel industry, the only thing I'm beholden to them for is the gasoline in my car and the gas to heat my home. So that was one of the things from yesterday. The other was I'm a firm believer in the scientific method, that this famous physicist who was one of my heroes, a Nobel laureate in physics back when I was in college in the 60s, and a member of the Challenger team that discovered that it was O-rings that caused the space shuttle to blow up back in January of 1986. Here's a couple of his favorite sayings that I totally agree with. The other thing we discussed in detail yesterday is what the real control knobs are on our climate. That being, of course, the sun, which heats our planet and keeps us alive. Water, as you can see, 71% of the Earth's surface is covered by it. And then planetary motion, which is a very complex part of our the way the Earth's water moves, the currents, as the Earth spins in its 24-hour-a-day spin cycle, dragging the water along with it, and the air along with it to create all the complex currents. And then there's the other planets around us, the planetary motion that's associated with gravity, and that. So that's what we talked about yesterday. Uh, so in my humble opinion, it's God that's in charge of those control knobs and not we humans or our SUVs or coal-fired power plants and whatever. So that's from yesterday. Today, oh yeah, the other thing that we talked about quite a lot yesterday is the difference between weather events, the red zigzag lines that you see there, versus the large time, large footprint climate trends that you see in the black curve on this. We talked about that. So it's important to recognize the difference between weather and climate, where climate is a large area, a large time average or trend, and it's important to keep these two in your mind. So today's agenda, what I want to talk about is more on the pollution side of um, what happens in our Earth, and I'll talk first about what's in that air we breathe, look back in the rearview mirror of history and talk about how we've been doing in terms of pollution, and then talk about the greenhouse effect, which is really important. And excuse me, I'm dry mouth. I need to take water every now and then. We'll talk about the greenhouse effect and weather modification. We'll talk about that a bit, and these everybody's saying that it's been hotter than ever, and I'll show you whether that's true or not. And then we'll talk about this something called the urban heat island and why that influences our weather when we compare it to what's happened in the past. So that's the agenda for the next 20 minutes or so. Um, so what the big God's eye view of things, the perspective of what we're talking about. Yesterday it was temperature, pretty much. And today we're going to talk about pollution, these being the major pollutants that we experience in our air. And the one that's called a pollutant that's not on the list, carbon dioxide, we'll talk about that again because it's a part of our atmosphere that we cannot live without. It's a source of life, one of the two sources for life, along with water, that keep us going on our planet. And then we'll get into energy a little bit and talk about fossil fuels and wind and solar and nuclear in particular. So that's the big picture of what Earth Day is about in my opinion. So let's start with what's in this air that we breathe. Before we get into that, it's important to understand we talk about carbon a lot these days, and carbon's a family of elements and molecules, the primary ones being these big three. Elemental carbon is what we think of as soot. Carbon monoxide is that extremely dangerous and deadly um, molecule that we all know about. And then there's carbon dioxide, which is the exact opposite of that, the one in the air that we can't, of the carbon family that we can't do without. One other thing before we get into the actual pieces of what's in the air that I thought was interesting and that I would like to share with you all is when we're inhaling, what's coming into our bodies from our lips are these molecules: nitrogen, oxygen, water vapor, argon, and carbon dioxide. And what we inhale in terms of parts per million or volume fraction or is over 770,000 parts per million, or 77% nitrogen in what we inhale. And then there's oxygen. Those are the big two, followed by water vapor that's anywhere from 5,000 parts per million in a dry place like Utah, where I live, to 50,000 parts per million in places like Bangkok, Thailand, that are very humid. Then there's some argon. And then there, at the bottom of the list, there is our 400 parts per million of carbon dioxide that's in the air that right now. So that's what we inhale. That's what's coming in at the point of our mouths. Now, what do we exhale? Well, as you can see here, um, of the oxygen and nitrogen, our bodies exhale a little bit less than we inhale. They're used by our bodies. Water vapor stays about the same from what we inhale to exhale, and same with argon. But then there's carbon dioxide, our 400 parts per million, or 0.04% to 40,000, 100 times more carbon dioxide from the air that we inhale to the amount that we exhale from our lips. 100 times more. So we are generators, we humans, all life forms are exhaling or generating carbon dioxide into our atmosphere, and we'll talk more about that. I just thought that was interesting. And so here's the differences. Our bodies are taking in or more oxygen and nitrogen. Our bodies are converting that to carbon dioxide and other things, and that's the difference between the two, ingoing versus outgoing. So what's in the air we breathe? Let's look at the list. Here's the good gases that we breathe from the air around us. Again, the nitrogen, oxygen, water vapor, carbon dioxide. It's a whole bunch of other trace gases. These are the good gases, to include ozone that occurs up high in the atmosphere. It's good up high, bad nearby. We'll talk about that in a minute. So this is the major components. And again, you can see here on the list that the two biggies are nitrogen and oxygen, and going downward. So those are the good gases that are in the air. And here are the gaseous pollutants that are up there as well. Carbon monoxide, a deadly one that luckily is a very small fraction of what's in the air. And then these other gases like methane and the nitrogen oxides and sulfur oxides we're going to talk quite a bit about in a few minutes. And then there's ozone again. When it's nearby, it's a pollutant. So as I said, good up high. It helps protect us from being too sunburned. It reflects ultraviolet light high up in the atmosphere before it gets to us and sunburns us too badly. And then there's nitrous oxide, which a lot of people get when they're in the dentist chair. It's called laughing gas also. Volatile organic compounds, and the bottom of the list, other fluorocarbons. So those are the green's the good gases, the red is the bad gases. We've got a few other pollutants that aren't gases, they're particulates. Lead in particular, there's a little bit of it in the air that we breathe and the dust that's around us. And then there's this thing called particulate matter, which is small, less than 2.5 micron diameter particles in the air. We call it PM 2.5, and smoke is the big one of those that fall into this category. And then there's the larger particulate matter, PM 10 they call it, and that's things like dust that we breathe. So that's what's in our air. Now we're going to talk about the difference between natural and human-caused pollution a little bit more. So how have we done historically and this plot shows that on the y-axis there are emissions in thousands of tons, and the x-axis, of course, is time from 1970 through 2023. And then you see the major pollutants. And how bad they were back in the 70s, or when I was growing up in the 50s in inner city Chicago, how bad the sulfur oxides and nitrogen oxides were in the smoke in the air and dust. And what a remarkable progress the Environmental Protection Agency has done in reducing those through catalytic converters and scrubbers in the smokestacks of our fossil fuel power plants and the like. And so we've done a really good job of reducing pollution in our air. And I hope that's the message I want you to take away from this slide. So now let me talk about the greenhouse effect, because there's this belief out there that those greenhouse gases are pollutants that are causing our current warming, current climate. So let's talk about what those are. Uh, as we know, sunlight, our major source of power, of heat and energy coming in to our Earth, is from the sun, comes through from space, interacts with our air, land, and sea, and during the daytime hours, and then the energy that's absorbed by our land and air and water is re-emitted back out to outer space as infrared energy at night, or terrestrial radiation going back out to outer space. However, when we have greenhouse gases in the air, added to the air, not all of that infrared radiation goes all the way back out to space. A lot of it, some of it, is uh, is absorbed and re-emitted in all directions, a part of which come back towards the Earth. Now, the greenhouse gases do not generate heat, but they reflect some of the energy. They prevent some of the cooling that would happen at night, that infrared energy going back out, by reflecting some of it back to the Earth. So that's the greenhouse effect in a nutshell. Now, what I'd like to talk about is that energy that's going back out to space. There's a physicist from back in the 1800s by the name of Schwarzschild that came up with this equation that shows how much infrared energy goes back out to space at night, and that's the the area under the curve in this plot right here. And on the y-axis is radiation back out to space in watts per square centimeter, and the x-axis from the left is infrared energy, and way out here on the right is visible energy that we see. And so this area under this curve translates to, if there were no greenhouse gases and a clear sky, meaning no clouds in the sky, our Earth would be about roughly 0 degrees Fahrenheit, standard worldwide temperature, average temperature. In other words, um, we'd be uh, frozen year round, if that were the case and there were no greenhouse gases. So the same curve now, the green under the curve here is actually experimental measurements. There's no questions about this. They pretty much follow that theoretical curve, but it's with greenhouse gases in the air now. So the area under that green curve is less, meaning less energy escapes to outer space and keeps us a bit warmer, to the tune of very convenient and comfortable plus 54 degrees Fahrenheit Earth temperature on average, with greenhouse gases, but no carbon dioxide in the area, just all those other greenhouse gases that I mentioned. Okay, this next curve on the lower left is again the theoretical curve. And now we add what we currently have today in the form of carbon dioxide also in the air, that greenhouse gas, to the tune of 420 parts per million, which is the current level that we have. And you see that the difference in temperature when we add the carbon dioxide in, it's lower than without the carbon dioxide, but the temperature is higher. It's a worldwide average of about a comfortable 59 degrees. I call it the Goldilocks temperature, average temperature worldwide of our Earth. So now, what if we double the carbon dioxide in the air? There's a lot of people out there that believe that carbon dioxide warms the earth. It doesn't. What it does is just prevent some radiation, cooling radiation from escaping to keep us a little bit warmer at night. So what if we now doubled that 420 parts per million of CO2 to 840 parts per million? How different is the area under that blue curve when we add double the carbon dioxide in the air? Well, the answer is it doesn't change very much. If you compare to the blue to the red curve, it's almost identical. And so let me show you again those curves a little bit easier to see. That's an overlay of the blue and the red curves, blue being the 420 parts per million, and the red being the 840 parts per million that we could theoretically, or what they've measured in the laboratory. And you can see they're almost identical. Blue translates to 59 degrees Fahrenheit, and the red translates to almost 59 degrees, or 59 degrees, like 0.001, a hundredth of a degree Fahrenheit warmer with double the CO2 in the air. So CO2 uh, follows the path of lessening returns for all the more that you put into the air. And we call that saturation. So if we doubled it again to over 1,600 parts per million, the curve wouldn't change. The area under the curve, which translates to the temperature, wouldn't change. That means carbon dioxide in the air these days is saturated. A little perspective, those also helpful when we look back again through the review mirror of history. We're here today at that 420 parts per million of CO2 in the air. And if we look backwards in time, this is millions of years before present, we see that carbon dioxide used to be a lot higher uh, than it is now. In fact, now we think of carbon dioxide as being fairly close to the line of death, meaning that if we went below this red line and didn't have enough carbon dioxide in the air, there would be no life. And we'll talk about why that is here in a minute. So the bottom line on greenhouse gases is that CO2, by the photosynthesis process, uh, is taking water and carbon dioxide in the presence of chlorophyll from green leaves, and the sunlight and the photosynthesis process is creating the oxygen we breathe and the food we eat through that photosynthesis process. And it's greening the earth, and satellite photography shows us exactly that. I'll have a picture in a minute, that over the last 4 decades, our Earth has consistently got greener than it was 40 years ago. And like I said before, CO2 doesn't generate heat. It prevents, it acts like a blanket, preventing heat, some heat from escaping to outer space, cooling at night. Uh, and so that's the story of the greenhouse effect. Like I said, there's this picture from the satellites that shows the greening of our Earth over the last 40 years. It's not a figment of anybody's imagination. It's infrared sensors, cameras that are measuring the continuing greenness. Even the edges of the Sahara Desert over the past 40 years have got greener than they used to be. And like photosynthesis, I said, as CO2 climbs, so does food via photosynthesis. The crops yields are increasing over time, whether it be rice or wheat or potatoes or any of these products. They're all rising thanks to the additional carbon dioxide that we're putting into the air to sustain our life. Now let's switch gears now and talk about this term that's come about of late called weather modification. And it's one of the things that really bothers me. So let's spend a few minutes on this. First, let's talk about remind ourselves that the weather is a natural condition, thanks to the sun, water, and planetary motion, and that the definition of weather modification is the deliberate alteration of this natural atmospheric condition by human activity as opposed to God's activity to provide the heat that we get, to modify, and the weather we experience. And it's a human activity to modify weather on local or regional levels. Has this been done? Well, yes, it has. And as a matter of fact, I was a part of that. Back in 1969, when I was 23 years old, well, first of all, here's the list of weather modification possibilities. And back in 1969, I was a member of Project Stormfury. I was attached to the Navy Hurricane Hunters. I was an Army second lieutenant attached to the Navy Hurricane Hunters, and and there was an attempt back at the time to spread out to lessen the impact of hurricane by spreading out the energy of a mature hurricane over a larger footprint. And so what they tried to do was seed the hurricanes from above with a combination of silver iodide and crushed solid carbon dioxide, um, and from Navy A6 intruder jets from above. And I was a part of the monitoring of that uh, experiment, which, by the way, had to be approved by the president to do it in 1969. It was done once, and that's it. And I was a part of it, and luckily I was a part of it. And I was in the planes flying at 1,000 feet above the surface of the ocean, the Navy hurricane hunters, just observing what was happening uh, uh, as they seeded this one and only hurricane. So that's cloud seeding of storms. Another form of weather modification is, again, cloud seeding, is dissipation of fog from airports. And that's where they just from the ground up, they shoot uh, pulverized carbon dioxide, uh, dry ice up into the air to pull fog out of the air near the edges of airports to boost safety of air travel at fog-prone airports. So that's the other thing that's done today and is useful, and it's not harmful. Again, it just uses dry ice, which is pulverized solid carbon dioxide. And so they've been doing that since the 60s as well. And I think they continue to do it. A lot of the Midwestern states that are subjected to fog. Snowpack enhancement's another form of weather modification. And it's, again, shooting dry ice, pulverized dry ice up into the air to pull out moisture from the air around ski resorts and for farmers and ranchers. This was tried back in the 1990s a little bit, but those ranchers in eastern Colorado and on into the Midwest didn't like this idea that ski resorts were doing this and sued and these downwinders that sued the farmers for taking away water moisture that would have otherwise traveled eastward and become rain and the humidity that they were no longer getting. So that went on for a little bit in the 90s. I don't. That's what I'm told anyhow, and I don't think they do that anymore because of the lawsuits that involved. The one other one that I didn't know about till just recently was this Operation Popeye that was back in the Vietnam War days, the late 70s, 60s, and early 70s. There was supposedly, and I don't know if who did it or what the details were back in the Vietnam War days to prolong the monsoon seasons over in that part of the world to pull moisture out of the air, to create more rain, to disrupt enemy logistics. And I don't know anything about that, whether it was successful or anything else. And then there's these stories that I'm hearing about today that we call solar geoengineering, also known as chemtrails. And that is when you take, again, something like uh, not carbon dioxide, but sulfur dioxide, and shoot it way up into the atmosphere, way up high to increase the cloud tops reflectivity so that more sunlight is reflected back out to space to cool temperatures at the surface. And the thought of doing this, putting a distinct pollutant, sulfur dioxide, back up into the air to cool the earth was a result of what was seen back in the early 1990s in the massive and explosive eruption of the Pinatubo volcano in the Philippines back in 1991. It ejected a huge amount of smoke and dust and the like, roughly 20 million metric tons of sulfur dioxide alone, very high up into the atmosphere, above 30,000 feet, which did, in fact, uh, adjust the reflectivity. It interacted with the cloud tops and changed the reflectivity of those cloud tops. So some sunlight that would normally have gone to the surface of the earth was reflected back up to outer space. And it turned out to be a measured effect of almost a degree Fahrenheit cooler worldwide for about roughly 2 years. So people, because of that, have thought about doing that again by taking large amounts of sulfur dioxide and shooting it way up into the air. And I think that is a really stupid idea. I hope it's not been done. I don't think it's been done, but there are a lot of people that believe that the government has been, or companies contract to the government have been doing it. They call that chemtrails. And I am close to this whole weather modification experience throughout my career. I've retained contact with those that we did it early, that one time, uh, not with sulfur dioxide, but with back in the 60s. And I am not aware, and I think I would be if anybody was doing that. But there are laboratory experiments I'm being told that are seeing whether it would work if we did do it. And there are a lot of people that believe it's already been done. And that's the chemtrails folks that, when you look up in the air at the trails, the white trails, contrails from aircraft, commercial aircraft flying up in the air, which is the water vapor that's being exhausted out of their jet engines, and high up in the air it's cold, and it converts quickly to solid water particles. And that's the white thing you see, is that we call contrails when you look up in the air. Some people think that those contrails are now turning orange, and that's because somebody's trying to put sulfur dioxide up there to help cool perceived climate crisis, cool the temperatures. So that's what weather modification is about, and that's what I think about it. That's my opinion. Um, I hope and pray that solar geoengineering is not done now or ever will be, because we do not want to put millions of metric tons of a pollutant back up into the air when we've been so good at pulling it out of the air from smokestacks of coal and uh, uh, power plants and natural gas power plants and the like. We've done such a good job of getting that out of the air. I think And I don't think it'd work, and I would think it'd be incredibly expensive. So there you have it on my view on weather modification.
Okay, I appreciate that, William. It's very profound and quite comprehensive. Let me ask you a question. In your, it sounds like you're still doing research and observations. Is the altitude in Utah, does that that are you doing research relevant to the altitude and what it looks like all over the country?
A single word answer, no.
Okay.
Um, it is what it is here at where I live in on the backside of the Wasatch Mountains in Utah. We're at 6,000 feet altitude, and we are not doing any research that I'm aware of on cloud modification. In particular, what we do is try and uh, tell the truth about research that I do in my retirement years now is on how we measure temperature compared to the way we measured it back in the 40s and 50s and 60s.
Okay. You have your own lab there?
No, I don't. I'm associated with a variety of groups, think tanks. They don't pay me a cent, but I listen to what they have to say. There's the Heartland Institute in Chicago. There's the CO2 Coalition in Washington, D.C., and there's others. There's the University of Alabama at Huntsville that does temperature measuring um, by satellites, but weather modification, no. The only one that I've heard of that's doing weather modification uh, as an experiment in a laboratory, not in the open air, and I don't know if it's true or not, is Harvard University a few years ago. But I don't know if that's true or not. And I haven't heard anything about it. I know people that have contacted Harvard and they won't even talk about what they do in their laboratories. So
I see. I
I
see.
don't know what's going on.
Are you positioned? You're not positioned to do any research, but if you
I
were,
am not.
okay, you
I
would
don't
take.
do, the
Mm,
only thing that I measure is temperature and humidity and air pressure and wind speed and wind direction. And I'll show you that in just a minute as
okay.
we
Yeah, but
come to a
there's room for that. I mean, because your understanding could train other students who might be able
yes.
to explore it a little better. And
That's what
with
That's what I
funding,
do out here in Utah is I talk to high school students and a lot of homeschooled students about
okay,
how to measure the weather
okay,
accurately.
yeah.
I
That's
have a
what I mean.
question, sir.
Go ahead.
Sorry. In regards to the vapors and everything, is there a way like where we won't be able to take in the air vapors, and will it cause like harm to us or anything if there's a chance that we won't be able to take it in? And then the second question is with the greenhouse gases, is there a way where they can stop that from happening to us, and will that also cause harm to us?
The answer to the first question is no, and the answer to the second, it won't harm us to pull stuff out of the air. Uh, it can be very expensive to do that, and to put stuff into the air, I think was your second question. Is yes, that would be harmful. As I mentioned, sulfur dioxide is one. We don't want to put anything that's a pollutant into the air. We do want to pull the pollutants out of the air by the things that we do, like sulfur dioxide. Uh, we prevent from coming out of the exhaust of fossil fuel gasoline vehicles and diesel vehicles by catalytic converters, for example. We remove the sulfur dioxide from the exhaust pipes with the catalytic converters. So the answer is
Mm.
yes,
Some,
we try to remove the pollutants. We don't want to put them back into the air. That would be harmful to put them back into the air.
mhm.
So then why are they allowing it to do like how you were saying about the greenhouse gases? Is that solely because of the like the trees and everything or
Yes, yes.
okay.
The
Okay,
greenhouse
yes.
gases are good gases. And the trees pull some carbon dioxide out of the air. The oceans, which are 70% of the surface of the earth, when the ocean waters are cool during the winter, they pull carbon dioxide out of the air. When it's warm in the summers, they release carbon dioxide into the air. But carbon dioxide is a gas, is a greenhouse gas that we've got to have. Without it, there's no life on this earth. It is not a pollutant. It's a good gas. The carbon dioxide and water vapor. And water vapor is the other greenhouse gas that we can't do without, as you could readily understand. I think we can't do without water.
Is there an estimation on the impact for electric vehicles? Because they're supposed to eliminate the gases into our planet. Is there any kind of minimal study that evaluates that?
Oh yeah, there's lots regarding electric vehicles. They are, quote, clean, meaning they don't have, except the what are they called, the hybrids that have both fossil fuel engines and electric engines within them, like the Toyota Prius, for example. But the truly electric vehicles are clean in use. But what you've got to look at is the whole story, the cradle to grave aspect of electric vehicles and the creation of the batteries in particular. And the magnets that are used in the electric motors come from rare earth materials that are expensive, they're rare, and the mining of them generate pollution because through the use of gas and natural gas and fossil fuels to do the mining. So with electric vehicles in use, they're clean, but when you look at the cradle to grave aspects of it, to get rid of the batteries, to do what needs to be done to bury all of those when they're finished or done away with, a tremendous amount of pollution is put into the air by the early and late ends of the electric vehicles' life cycles. The other thing about electric vehicles is that that process of creating them is expensive. They're more expensive than our traditional gas and diesel powered vehicles that aren't as clean as them.
So you're saying to develop the battery
Oh
is
yeah,
not clean, and then to dispose of the battery is not clean.
not just the battery, but all the parts of the electric vehicles. The electric motor parts too are hard to put to bed at the end of the life cycle.
I see.
Yeah.
I see. Huh, that's interesting. Didn't know that.
Yeah.
Mr. D'Souza Brian, is there much use do you know of in India? Is there a use of a green bat or a green vehicles there?
Yeah, you can hear me? Yeah.
Yeah, I can hear you. I can hear you.
Yes,
Okay.
the use of green vehicles has gone up substantially. Yeah.
So I've heard too.
There is an incentive also to use the battery powered vehicles. But of late, there has been a little, push from the environmentalists saying that batteries are even more polluting, the electric batteries rather are more polluting than even having the fuels, the using fossil fuels. So in the long term, because once the life of the battery is over, then, when we need to get rid of these, so there's a lot of pros and cons. So, but of course, there new talk of the new type of vehicles, which I think hydrogen based, if I remember correct. Yeah. So there, I don't know. I mean, it's a very initial stage,
Yeah.
but
Okay. No,
yeah, but because charging points for vehicles is not easily available electric as yet. Most buildings and places don't have charging, so the ease of use may not be there as yet.
No, by the way, the charging stations for the electric vehicles, if you look behind them, I don't have it in this presentation, but I've got a
Yeah.
picture of a charging station in Australia that is
Yeah.
charging electric vehicles, but that charging station is powered by a diesel generator.
Oh, boy.
Yeah,
Oh, boy.
so
So, wow, that's not good.
there's no free, well, yeah, but there's just no free lunch in this whole.
I see. So on the one hand, while they make it, but I mean, you're only talking about access 0.5%, half of of a point of use. And even so, that kind of people aren't moving in that direction. There's no need to. I mean, they probably aren't compelled by government to do it. Even here in the US, they were at some point compelled to do it, but they're not right now. And so, what kind of
Yeah.
consumption would they have?
We'll see what happens.
Yeah. Well, wow.
Hmm.
Are there any other questions for Mr. Pinkney? I really, really appreciate your insight and exposure.
Let me just finish real quickly with just the last few slides, okay?
Okay.
So this is a picture of the Navy Hurricane Hunter aircraft that I flew in back in 1969. Again, as I said, the Navy intruder jets from up above the hurricane, Debbie in particular, in August of 1969, they dropped the pulverized dry ice and what's it called? Nitrogen something or other in from above. And there were 22 people on this aircraft, a few of which were meteorologists like myself. We flew into the eyes of the hurricane in a racetrack pattern coming in through the rain bands, perpendicular to the rain bands, and then cutting into the eye wall and turning around within the eye wall and going back out in this racetrack pattern that was about 250 miles long by about 50 miles wide, flying at just a mere 1,000 feet above the surface of the ocean with these amazing Navy pilots. I was just a crew member on board, a meteorologist that was measuring whether this was whether they were effective by seeding the hurricane, turning it and spreading out its energy. And I was sitting there behind a radar screen with a camera bolted to the front of it, taking pictures to decide if this seeding of the hurricane would turn it away from land and spread out its energy. And the bottom line on all of this was one word: inconclusive. We could not tell whether the seeding of the hurricane turned it and spread out its energy, or that would have happened naturally all by itself. So it was inconclusive. And that is part, and maybe a great part, of why it was done once and only once. So that's the aircraft we flew in. There's just another picture of it. It's Weather Reconnaissance Squadron 4 of the US Navy Hurricane Hunters of the time. This is before satellites were watching for incoming hurricanes. They did it by flying into them, and then we monitored I sat on board this and monitored the seeding, the one-time only seeding of Hurricane Debbie in August of '69. So again, here's all those examples of cloud seeding, with the solar geoengineering part of it, a really bad, expensive, stupid thing to even try. So just a quick conclusion to all of this. Let me talk for just a minute about offshore wind, another form of clean energy that's being pursued. It's very expensive. And my opinion, this is not me with any empirical evidence other than what I'm going to show you in just a second, but my opinion is they're unpredictably intermittent. They're intermittent because they only work when the wind blows, and they're really expensive. They break a lot. Those humongous wind turbines. So they're unreliable, environmentally destructive. Getting them rid of them again at the end of their life is expensive, and it doesn't reduce carbon or save the planet from catastrophic climate change. But then again, climate change in my mind is not catastrophic. It's cyclic, and it's been happening for millions of years. So that's offshore wind, which has been going gangbusters, putting these up off the Atlantic coast and in Europe, off their coastline in the North Sea, above Germany and the like. And I don't know what's going to happen in the future. I'm not very optimistic about wind power, especially offshore. It's just too expensive. And this is one of the things that's been happening since when the offshore wind's been being put up over the last few years. They're seeing 10 times as many whales dying as a result of the various things. Just the construction going on and harming them, the low frequency, consistent wind, not wind, but sound produced by these things that affect the whales. Anyhow, we're getting a lot more dead whales than we used to.
Is there any reason why you think that? Do they know why that is?
Yeah, they think it's a variety of reasons. The construction efforts are confusing them and bothering them. The noise from the wind turbines are bothering them, and who knows what else. There's still a lot of research going on there, but
But this
there's
is
a lot
offshore.
of pushback from offshore wind going on by the state of Virginia right now, in particular. And then going northward up the Atlantic coast against doing offshore wind.
Hmm, hmm. So
So I
is
don't
it?
know. Go ahead. And then there's a lot of these offshore, not a lot, but a few of the handful of offshore wind companies that are going bankrupt.
Because they can't
So,
find people to buy the services.
well, yeah, because they're hearing these bad things and they're getting pressured. So I don't know whether that's going to succeed or not. My opinion, though, here.
Okay, appreciate your insights, Bill.
Okay, so one last thing, hottest than ever. We hear a lot about that. It's warmer than ever, warmer than it's ever been. Here's how that thinking goes. Again, it's the carbon dioxide byproduct of the combustion of fossil fuels that's warming our planet, or so they think. It's a greenhouse that hinders air from cooling normally at night. That is true. It's steadily increasing in the air. That's true also. But hence the activists or alarmists think that air temperatures being getting warmer because of it. Well, and that's not true. And again, when you look backwards in time at history, today is here on the left. Carbon dioxide was much lower over here on the right today than it was back in the early days of the planet. And temperature is not nearly as hot as it was way back when. Urban heat islands, last thing I'll talk about, and then get off the stage here. Because this is hotter ever comes from the fact that our current weather stations and the way we measure temperature right now is with electronic thermometers. In the past, in the 40s and 50s and 60s and 70s, we used mercury bulb thermometers. They're different. And then, but what we're seeing is this phenomenon of urban heat island, which says that temperatures are getting significantly higher, but they're getting higher in urban areas and not so much in rural areas. And the temperature differences between urban cities and the like and rural countrysides and the like are as much as 7 degrees Fahrenheit warmer in the cities. And that's what we mean by urban heat island. So people are saying it's hotter than ever now, but they're sitting in downtown Chicago, for example, where the temperature being measured at O'Hare Airport on the tarmac next to the runways, the concrete runways that the temperature sensors are measuring the concrete. They're measuring the asphalt. The weather stations are sitting on the side of our highways and interstates, measuring again the temperature of the roadway, not the air temperature that used to be from the countryside back in the 40s and 50s. So we're seeing warmer weather now, even hotter than ever, was measured back when the weather stations were sitting in the middle of the rural areas of the United States. There's the key contributors that I mentioned, and so here's a weather station that I happen to own. It's properly sited, meaning and this is the NOAA, National Oceanographic and Atmospheric Administration, and the U.S. Weather Service regulation that says all weather sensors, and the weather sensors here are these things right in the middle of the triple redundant. The sensors are just protected from airflow and bugs and the like and dust by these white things here. But they're supposed to be at least 100 feet from the nearest heat source. And this one near my house is 100 foot all around, with no buildings, no concrete, no asphalt roadways or anything else. And so I'm a part of a project to look at the weather stations around this area in Midway, Utah, where I live in the Heber Valley, where the weather stations surround in the area all are sitting right on or next to highways and the airport, the local airport here's being affected by the concrete and asphalt, where this is not. So we're looking at whether we're really experiencing the hottest ever temperatures these days. So let me summarize and get off stage now. We all, and this not new news to any of you, we need to be good stewards of our planet and keep it clean, whether it's air, land, or water, or all of the above. We need all forms of energy. I don't think that wind and solar need to be our primary forms, but we shouldn't get rid of it totally either. We need everything we can get, especially with AI coming on board and the electricity demands that it makes or is going to make as we go forward. Our weather and our climate, as I've explained, they're always changing. It's cyclic. I want everybody, and especially in impressionable youth, to not be afraid, to know that they don't need to be afraid of climate change. It's cyclic. So just study it and respect for it and prepare for it. And perhaps we should simply also be adapting to and enjoying this warm hand that Mother Nature has dealt us. So let's not, in my opinion, again, waste trillions of tax dollars on a minuscule change to come out of net zero that may or may not improve our temperatures by a small fraction of a degree Fahrenheit. So that's it. The bottom line again is this billboard where there is no climate crisis. As I explained earlier, that carbon dioxide is saturated in the air. No matter how much more we put into it, any warming from it's negligible, and that's the bottom line. This is me, my cell phone number. Feel free to contact me, whether you agree or disagree. Or if you want to buy a book directly from me to get a signed copy, feel free. So that's the information about me and where you can get my book. I'm now in the process of writing a second book, which will talk about climate a little bit more and update it a little bit, but it's the title of this new book is Memoirs of a Soldier Scientist. And it's going to look at my whole life and including my Hurricane Hunter days and all of that stuff. And hopefully it'll be out by the end of the year. My wife doesn't believe it for a minute that we'll get it finished and printed by the end of the year. But that's what's occupying me in retirement for the next several months, big time. And so that's it. And oh, here's what I wanted that Elizabeth asked about me earlier. These are 3 really good places to go if you want to learn about what I've been saying, in addition to what the other side says from the various sources. These are 3 that I really respect, and especially this guy, Dr. Roy Spencer. He's a meteorologist that is above and beyond anybody. He's the greatest. He and his partner, the state meteorologist from Alabama, and now I'm not remembering his name either, but these guys at this website, drroyspencer.com, and all 3 of these are really, really good that write on these websites.
Mhm.
So that's it. I'm
Okay.
done. Thank you
Okay.
very much. I appreciate the time.
Thank you so much, Bill. I appreciate your input, your insights, and your research. Also, if you don't mind, could you PDF your slides? And I'd like to keep a
Yes.
record of them if it's okay with you.
Yes, I will do that. They will also have my notes with them that you can the slides themselves. You didn't see the notes that go with these things.
Okay, that'd be great. That'd be
Yeah,
great. If you could do
so
that ASAP, that'd be fine. Because you've got great insights, great information. And while there's some things that maybe we don't completely agree with, but you did your research and gave us an insight of your point of view. And that's the thing about science or research.
yeah,
You know, you can get about the business of proving something wrong or theoretically.
only one experiment away from being proven wrong.
Yeah, exactly.
Let me
Exactly.
just say one last thing about exactly what you're saying. Back in the 16th century, the worldwide belief was that the sun revolves around the earth, and there was every reason to think that. If I had lived back then, when I got up and went outside during the day, I see the sun rising in the east and above my head in the midday and setting in the west. And I would say, yep, that sun is rotating around me. That's what they believed back in the early
Yeah.
1600s until the telescope came along.
Right.
We're
Right.
able to see way further out into space and measure the truth, which is that no, the sun doesn't revolve around the earth revolves around the sun.
Yeah, there's so many aspects of science and research. Of course, eons and eons ago, they believed that the Earth was flat. You know, so I
Yeah,
mean,
yeah, that's the other thing. Yep.
I mean, the theories that we have come to understand and proven to be untrue, and there's so much that we won't, don't, and may never know. But you know, it's important that we come to a point of learning. Learning. I mean, even as you hear about the solar caps melting, which leads to a larger supply of water and seawater, and all those
Yes.
things will impact our lives.
And
Yeah. Yeah.
like Einstein said, we're only any true scientist is only one experiment away from being proven wrong,
Yeah. 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 So
including me.
so I really appreciate your insights and input, your Bill, and stay tuned. We also will keep up with you and let's keep talking about. And then we want to give you an opportunity, and if you'll do a refix on how your perspectives of science will come on
Yeah.
us to take a look at medicine and that kind of thing and the treatment of those things. That we appreciate it. So I'm going to swap out and
Thanks for having me. I truly am honored to be a part of.
thank you. Thank you so much, Bill.
Thank you.
And also, I encourage Brian, your input from a South Asian country point of view in terms of science and understanding. And I really want to spend some time with you to talk about future industry perspectives and AI. And
Oh yeah.
and that kind of thing, what that means and what it can mean, and how the industry and the countries are changing. And internationally, the impacts of tariffs. Let's really plow into that and take a look at what's around the corner. Because we're representing a business community that really has to evolve. You talked about this yesterday, and I had some further time to talk with Mrs. Bradford, and we were exploring what the prospects of small business and bigger business community from the standpoint of Canada and South Asia, and we have some representatives from Australia, and trade. Trade is huge, and trade will be huge, and there's no way that our economies can replace trade. You look at the number of containers that travel back and forth between the U.S. and other countries. I mean, this is a big deal. It's a big deal. So, with that being said, we have some other speakers, and we don't have a whole lot of time. But Reginald Larley is going to be coming up, and I'm going to swap out and let my colleague and cohort Claire come in and represent. Okay. Oh, so long. We'll talk soon. Bye bye.
Thanks again. Bye.
All right.
Thank
bye-bye.
you, Bill.
Okay, Bill, you can stop sharing. Yeah, all right, let me, you're watching Discover Brightside. Make sure you subscribe. Thank you, Bill, for the knowledge. And science is something we might not agree on, but the facts are the facts. And he's a scientist and he's given us the facts, and we have to respect those facts, whether we want to get involved with what the world is saying, but the facts are the facts. And he's laid it
Until we're
out,
proven wrong.
spend time to share this with us. And this is great knowledge. So thank you so much. And
Sure.
Bill, I know you're going to get busy, but let me stop recording. I want to, before you leave, I want to say a few things. So thank you for watching Discover Brightside, where we discover new things. And we want to make you live the best that you can be. So we try to give you the best knowledge, the most accurate knowledge, so that you can know for sure what you can count on, all right, at this time of the world. So just a quick plug-in. Bill is offering a special promotion for 2 climates. You can get an autographed copy at his website, and watch for our reviews and promotions that we'll be doing all summer long. This is a very important time for you to get this book. Thank you.